Right, so chapter 6 is on rational expressions and equations. And so we are going to start off with how to simplify or reduce them. Then we'll move on to how to multiply and divide with them, then to add and subtract with them, then to how to deal with complex fractions, then how to do equations with rational expressions, and then do some applications of them. So 6.1 is on evaluating and reducing rational expressions. So rational expression is where you have a polynomial divided by another polynomial. So because you're dealing with division, you can't divide by 0, that means this polynomial in the denominator cannot be 0. So we can figure out what values would need to be excluded to make the expression defined. So in other words, when the denominator is 0, the expression is undefined. And when it equals 0, then it is undefined. And we want to sometimes know what values make it undefined so that we can restrict the domain, restrict our inputs to not include those, or at least recognize what the restrictions are. This also matters when we go to deal with equations because we can't have a solution that would be a restriction. And it comes up in calculus quite a bit. And when you're graphing, it looks different when where you have zeros as a denominator. So in any case, when you're evaluating rational expressions, you're just plugging in a value. So if I evaluate at 6, you're plugging in 6, and you reduce. When I plug in -3, I end up getting that undefined situation because you are dividing by 0 because -3 plus 3 is 0. Plugging in 8, you'll notice that I have a fraction and it can be reduced to 1. So we're going to have some cases where it can't be reduced, some cases where it's undefined, some cases where you can reduce. And those are just with nice numbers. But now we're going to deal with the expression as when you have variables and polynomials in there. So restrictions are values that make the expression undefined. That is what makes the denominator equal to 0. So all we care about is the denominator. So in this case, what makes this 0? We can determine that by using our factoring method from the last chapter. So I factored out the greatest common factor of x, and then this trinomial with a leading coefficient of 1, I use my little x trick. What multiplies to -3 and adds to 2 is 3 and -1. And so then what makes this expression equal to 0 is what makes any of the factors equal to 0, because 0 times anything is 0. So what makes this factor 0 is 0. What makes this factor 0 would be -3. What makes this factor 0 is 1. Just the opposites when it's linear. So all of these would be considered restrictions. So what are the restrictions? Those 3 things. Any of those 3 would make this expression undefined. The restrictions on this, what makes this 0? Well, I say none. The reason for it is because whenever you square something and you add 10, you're not going to get 0 because you're always going to have a positive when you square something. And then when you add 10, you're never going to have 0. The smallest thing you could have would be 10, from 0 squared, plus 10 being 10. Algebraically, you'll have the square root of a negative, which is an imaginary number. We will talk more about that in a later chapter. But for now, right now, what you should realize is you cannot take a square root of a negative in the real number system. So that doesn't happen. Here's another one just to practice. You see that's a difference of squares. You can do it by square root method, kind of like what I did up above. Isolate the x squared, take the square root. We'll learn more about this method later. For now, you're probably more familiar with, and I would expect you to do the factoring method. So it's a difference of squares, and what makes the 0 is 5 or -5. So that's the restrictions portion of the lesson. The next portion of this of 6.1 is on actually reducing these. So the steps are to factor, and you want to think about the restrictions then, because you can't divide you can't divide your problem by 0. So you can't have a 0 in the denominator for this expression. Neither for this, but it also applies to your original problem. So these are only equivalent, they're only actually equal when we take note that this can happen when m is 3, but it also is only equal when we take into account the fact that it also could not have had -5 for your m. It would be undefined there. And that comes up again has more of an impact when you're in calculus. But for our purposes, again, think about the restrictions. At any point you cannot divide by 0. So factoring this and factoring this, here's my little X trick. I see that there's a common factor. M plus 5 goes into m plus 5 one time. We often don't show the ones, but they're really there. So we're going to be left with m plus 2 times 1, so m plus 2, and 1 times m plus minus 3, so m minus 3. So there's my answer. These m's cannot cancel. You can never reduce terms, only factors. So I reduced these because they are factors. It's something times something. I cannot cross cancel the m's because they are, this is a factor. The whole thing is a factor. M is just a term. Cannot cancel terms, only factors. So here's a couple more practice problems. A lot of practice with factoring is going on here. So I'm going to kind of go through that and give you a little bit of a reminder about the different factoring as we go through it. Here, there's a greatest common factor of 3, then it's a difference of squares. Down here, it's 3 terms, so make your x, multiply your a times your c, put your b, figure out what multiplies to -12 and adds to 11. Once you've figured that out, that's how you're going to break up your middle term. Because a is not 1, you cannot just use those values in your factorization. You have to do your grouping. So break up your 11x. This can be done even when a is 1, so you can always do the grouping. It's just not necessary when a is 1. But since a is not 1, we must split it up, do our grouping, get our common factor and our leftovers, and then we look for any common factors. Our answer is whatever 3 times 1 times x minus 6 is. You can leave it in factored form, or you can go ahead and say 3x minus 18. It's okay to be in factor form. I actually prefer it because it makes it easier to see the factors being canceled and less room for error in continuing and multiplying it out. And then the denominator is 2x minus 1. The restrictions are at any point. So -6 would make this 0, and 1/2 would make this 0. You find that by setting them equal to 0 and solving for x. Or you might recognize or be able to do it kind of in your head. If I set this equal to 0, you'd add 1, and then you'd have to divide by 2, so 1/2. Here, if I set this equal to 0, I'd have to subtract 6. 0 minus 6 is -6. This one looks like it might be in a good position because it's already factored, but that's not very helpful. We want it to be completely factored. It's not. It's subtracted. So we need to distribute so we can combine our like terms. Now we can factor that. That's a difference of squares, and it cancels out with that. So x plus a divided by 1, which is x plus a. And the x cannot equal a, the a cannot equal x. The variables just can't be equal, otherwise you would get a 0 in the denominator. That doesn't show up too often, but it's just kind of a nice comment about when you have multiple variables, how to handle it. This next example, the a is not 1, there is no common factor, so I'm stuck with an a that isn't 1, so multiply the a times the c, put down your b, what multiplies to 45 and adds -14, then do your grouping. Here the equation is not in standard form. Putting it in standard form would be -x plus 3. To factor that, I mean, it's really as factored as it can be, except that it's nice to have our leading coefficient of our factors be positive and it's negative, so we could factor out the negative. And that will make it match up potentially with other things, as you can see here. But we do have -1 down here. And so when I divide both of these by -1, there, that would be my final answer. And the restriction would be what makes the denominator 0. So 3 minus 3. You cannot have x be 3. You can see it also here. 3 minus 3 would be 0. So -0 is just 0. So that is 6.1.